This video is about parent functions. So what we're going to be talking about today is called parent functions, and we're going to bundle this with an idea called transformations. So what we have on the screen here are our three basic parent functions that we're going to be talking about for a pretty good while. Get a linear function, which you're used to, a quadratic function, which you may or may not have gotten to in algebra last year with, all the COVID stuff, and then the absolute value equation, which might be new to you. So let's talk about linear first. So linear is this guy over here, y equals x. That's the parent function. And you've used this as y equals mx plus b before. So the m and the b let us transform this particular equation. The m, or the slope, is our vertical transformation. What I mean by that, it's actually kind of a misnomer. It lets us either stretch like up and down or stretch like side to side. We call that a vertical stretch or a vertical shrink. So when you have a vertical stretch, you also have a horizontal compression. When you have vertical shrink, you have a horizontal stretch. So it's a little bit weird. Let me show you what I'm talking about. And I want to be really clear. I'm going to sketch these. They're not going to be the prettiest. Actually, I'm not even going to use a ruler. So don't judge my graphing here. It's just a sketch. So if I was to take my parent function and stretch it vertically, it would look maybe like this. You see it? How it looks like I pulled it up and down more? That's the vertical stretch I was talking about. So if I wanted to do a vertical shrink or compression, you're talking about making it kind of shorter and wider like this. So that would be the shrink or compression. That's what the m value does. The other value, the k, the b in this case, I'm sorry, will push the graph up and down. So instead of it meeting the y-axis there at 0, maybe it meets it at 4. So this would be what happens when we change the k value, or the b value in this case. It changes the y-intercept location. Quadratics work very similarly, except they don't have an m value. They have an a value. They've also got h and k. H is our horizontal shift, and k is our vertical shift, which is why I kept using k for vertical shifts before. The only kind of weird part about these is that h is the opposite of what you think it does. So if I gave you an h of a positive 3, when you graph it, it's actually going to have negative 3. It's going to be shifted to the left. It's a little bit weird at first, but you get used to it pretty fast. A is the vertical stretch or compression. So that's going to either make our U steeper if it's a stretch, or fatter if it's a compression. Kind of like that. If A is negative, then this is going to flip over. So if A was -1, for instance, then we would just take our graph and just flip it. So if A is negative, it reflects the graph on the x-axis, making it open downward. If A is positive, it opens upward. If it's a vertical stretch or a horizontal compression, if our A is a whole number, it's a vertical shrink if it's a fractional number. The vertex of any parabola is going to be h, k. The inside moves the graph right and left. If you want to know what the horizontal shift is, it's x minus h equals 0. Basically, it's the opposite of that h value. Absolute value works pretty much the exact same way, except it's a V shape instead of a U. And the A is going to be the slope. Super straightforward. HK is still the vertex. H is still the horizontal shift. And K is still the vertical shift. A horizontal shift is still always the opposite of the number, and k moves the graph up and down. So let's take a look at what some of these look like worked out. So I've already completed these. I did the parent function in the blue, and I did the transformation in the red. So for example, A, for instance, the first thing you notice is that I shifted it down -4, and I changed my slope just a bit. I did 1/2. I actually think I might have graphed that wrong. I did. Oh my gosh, what a terrible teacher I am. Let's fix that right now. Look at me, I was just trying to be smart. All right, so let's fix h of x real fast. So it says I've moved it down 4, so 1, 2, 3, 4. Make my y-intercept. Now it says my slope is 1/2, so it's 1/2, like this, which definitely changes what the angle looks like, my goodness. And this would be our h of x. So you can see not only was it the vertical shifted, but we had a compression vertically, which we can say vertical compression. Compression vertically. Geez, I'm just not doing well spelling lately. Vertical compression of 1/2. All right. Let's look at the next one. Again, the parent function y equals x squared is in the blue. For this particular one, we're going to look at our a value is 1, so there's no compression here. Our h value, it says is 3, which means we're going to move it left 3. It's really -3. So we moved him over 1, 2, 3. And the k value is -2, so we moved it down 1, 2. And we have our parabola shifted to the left and down. For c, we have an absolute value. We do not have an a value, so there's no compression. There's no change there. And my k value is 0 plus 0 minus 0, however you want to say that. Our h is going to be -3, which means we're moving to the right 3 spaces. So it's just this V shape moved over 3. All right, let's look at D. In D, we have an a value here. The a is -1. And we do not have an h value. So it's not moved side to side. But the negative means I flipped my graph upside down, which you can see here in the red. And then the +3 means I have taken that flipped graph and I have pushed it up 1, 2, 3 spaces on the y-axis. So it's a reflection and a vertical shift. On E, we have a lot going on. My goodness. So to start these, I always do HK first. So our H says we're going to move it to the left 4 spaces. We're going to move it, and the K says move it up 3 spaces. That -3 is going to be that vertical stretch. And it's going to be upside down because of the negative. We've compressed it, flipped it, there we go, and moved it over. So for F, for a problem like this, I always look at HK first. So here I see it's moved over 1, 2, 3 to the left. So +3 is going to be in my H in the absolute value bars. And then it's 1, 2 down, so -2 for my K. And then I looked at the slope. My slope is up 1 over 1, 2, 3. So my slope is 1/3, which means my A is 1/3 for an absolute value equation. That's really all there is to identifying. Number one, identifying your parent function: linear, straight line, quadratic, that parabola, that U shape. Absolute value is going to be the V. And our transformations, generally involving A, H, and K for quadratics, absolute values, cubics, any kind of polynomial equation. And then for a linear equation, y equals mx plus b, with the m and the b being what does our translations.